Hi, I'm Darren and welcome to Level Up EE Lab. I'm relieved to report that my Heathkit line voltage monitor still shows I've got a solid 125 volts main voltage here in the lab. But more importantly, I've made some solid progress on the repair and restoration of my Heathkit DX-60. Let's check it out. Let's get this episode started with an update on the chassis. I decided to paint it, but only the top and back surfaces. Those are the only ones normally visible anyway. And keeping the other surfaces unpainted means I'll still be able to make good ground contact with the chassis. And here's the finished product. I used a hammer finish spray paint because the chassis is pretty rough and pitted in many areas, and putting a glossy or matte finish on it would have just made those defects more visible. Other than a bit of unevenness in the gloss, I think it turned out just fine. It's definitely a big improvement. Okay, moving on. Let's cover the power supply section of the schematic next. There are 3 DC voltages here, a negative 100 volts and 2 positive voltages, 300 volts and 600 volts. The construction of the DX-60 power supply uses lots of leaded components and one multi-section capacitor. I'm going to replace all of that with modern radial caps, which means I'm going to need a printed circuit board. And actually, I ended up splitting it into 2 PCBs. This one here is for the negative 100 volt section, and the second one here is for the dual high voltage section. I did have to drill one new hole for the standoffs. Here's the schematic for the negative 100 volt section. I'm using 22 microfarad caps here because they're the closest larger value to the original 20 microfarad ones. And here's the 3D model of it. Not much to it, it is pretty simple. The dual high voltage section is a bit more complex. There's 4 total caps, and just like for the first one, I chose the closest modern equivalent values, 47 microfarad in this case for the stock 40. There's also 2 jumbo 10 watt 100 ohm resistors. The stock design used 7 watts, so I went a bit larger here. Once again, the obligatory 3D model view. I was going to take some video of both of these boards after assembly, but I forgot until after I'd already installed them into the chassis. Jumping back to the schematic, notice these 15K resistors right here at the output of the high voltage section. They're not separate resistors, they're actually a center tapped 30K 25 watt tubular power resistor that's attached to the top of the chassis. Heathkit put it there more than likely because it runs hot and it needs convection cooling. And of course, the one in my rig is open circuit on one half. And naturally, a replacement is unobtainium. Luckily, a modern equivalent is pretty easy to conjure up. I'm just going to use a couple of 10 watt radial leaded power resistors. Which means I'll need yet another circuit board. It's very simple, there's hardly anything to it. The hole in the center aligns with the existing hole in the chassis where the original was mounted. Here's the assembled board. Each resistor has to dissipate about 6 watts, which means this little module is going to run hot. Up next is an important modification that I need to make, adding a push-to-talk function. Not having that is one of the main reasons the function switch sees so much wear and tear. It's pretty easy to add such a mod. Several ideas exist for how to do it, but one of the best is the one by Terry. He shows his version in detail on his YouTube channel D-Lab Electronics and even offers the modification as a kit. I decided to roll my own version, mostly because I've already got a pretty hefty layout for this rig already. So here it is. I'm using 2 relays here because I want to support 3 functions. The first circuit will key the rig to transmit, the second circuit will send AC power to the accessory socket for an external antenna relay, and the third will control receiver mute. The fourth pole, well, it'll just go unused. The source of power for the relay coils will come from the 6.3 volt AC filament supply. That can power 12 volt DC relays by using a clever bit of voltage doubling and rectifying. What I'm doing here is the same approach that Terry uses. It's called a Greinocher voltage doubler. And yes, I did have to look that up. The capacitor values I'm showing should actually be larger. In fact, 1000 microfarad would smooth out the ripple quite a bit more. But I forgot to include those in my parts order, so rummaging through the parts bin, these are the highest values that I had with a high enough voltage rating. Of course, I whipped up a quick simulation. And based on the results, I should be fine. The ripple is pretty pathetic, almost 2 volts, but it never drops below the minimum hold voltage for the relays. Resistor R2 is just a bit of series resistance to keep the peak voltage at the relays comfortably below 12 volts and can be tuned if necessary. R1 is there just to discharge the caps on power down. Building it requires, you guessed it, yet another circuit board. I'll have 4 of them in this rig, and all of them will be home etched. My technique is very refined now. I got all 4 to turn out great on the first try. And here it is all populated. And like Terry's design, I'll just use some double-sided foam tape to stick the tops of the relays to the chassis, so no hold-down screws are needed here. Are you ready for some assembly? I sure am. The process kicks off with installing the tube sockets. V1 and V2 use ceramic sockets, and I'm reusing the old ones because they're still in okay shape. I even left the ceramic caps on because they checked out fine. I suppose I could record the entire assembly process, but I don't think you guys would sit through a video that long. So I'll just stick with the highlights. Like this one, installing the transformer. It's actually easier to install the chassis on the transformer rather than the other way around. And after it's in place comes the wiring harness. So I think I'll just pause recording now and pick it up again after I get it all in place. Alright, I've got the harness in place along with making the solder connections to most of the items that it connects to. And so what I've been doing, of course, is following along in the step-by-step procedure in the Heathkit assembly manual. I showed earlier putting the tube sockets in, and just continuing, I've gone through pages 11, 12, 13, and 14 are all about the breakout points on the harness and where to solder them in. Of course, some connections you don't solder if they're going to have more than one connection at that point. And so I'm up through page 15 right now, and things have gone very well. I did a good job, as it turns out, with the lengths I made all the individual wires. Everything was at least an inch or so longer than I needed, so I didn't run too short on any of the connections. Obviously, I've got the negative bias power supply board in place, and I've got the high voltage board in place. Everything seems to have fit nicely, no major issues. I would comment though that I did make the right call in lacing this harness, because as I dropped it in place, I noticed right away there's barely enough room to fit it to the sides of these terminal strips here, and of course underneath the function switch. In fact, part of the assembly procedure, you make these bottom connections on this function switch before you even put the switch in place. There's just no room to do it otherwise. So if I had that split spiral tubing or loom on this harness, I definitely would have had a problem getting it to fit in there. And there's a few connections over here that aren't made yet. They're just normal process as part of the assembly flow. Also, these down here for the power supply, those come later. And then the last thing I comment on this point, I haven't put the push-to-talk module in yet. Here's the connections for it. I will do that later in the assembly because there's some mechanical components in this region. There's a metal shaft that comes through here, and there is enough space. It's not that it's going to be too tight to fit this in there, but I don't want to accidentally put it, half an inch over in the wrong spot. So I'll wait till later to put that in. Time to check in on my assembly progress, and what I've done here is I've almost completed the modulator wiring, and that's this section up here on the chassis, and it would be pages 16 and part of page 17 in the assembly manual. I say I've almost completed because there's one resistor I haven't put in. There's a 33K 2-watt resistor. It's labeled R31 on the original version of the DX-60, not the DX-60A or the B. They changed the component part numbers as they progress the models on that. Here it is. As I mentioned in the prior video, I did buy some carbon composition resistors. I have a reason why I did that, which I'll talk more about at the end of this episode. But unfortunately, this looks like it's probably new old stock. I did buy these through Surplus Outfit, and I know there's a risk there that these things will even drift over time on the shelf, and this one did. It's no longer 33K, it's 43K. So that's not going to work. So I'm going to have to skip over that step for now and put in an appropriate resistor later. I also did not connect the neon lamp here, the power on indicator lamp. The leads were just too short, and it's really dim even when it's powered on. So I've been kind of hesitating what to do about that. But for now, it's not connected. It's no big deal. So now, next up, I have to skip over the section in the manual on the power supply because none of that is applicable anymore. And so next up is the oscillator wiring. So let me get started on that. Progress. I have finished the oscillator wiring and the final amplifier wiring sections of the manual, pages 18 and into part of 19. And a little bit of the general chassis assembly, and I think this is a good break point to talk about a few things. One of which is this resistor right here. This is R13. It's an 8.2 ohm resistor on the cathode to ground. That's an important part as you study some of the things that folks have learned about working with the DX-60, because if that resistor drifts too much over time, you're not going to be able to set the current, the load current correctly on that final tube. In worst case, you may even damage the meter, because if that resistor goes open, it can create havoc with the current that ends up going through the meter. I did put in a metal film resistor here. I think it's fine from what I've read because it's bypassed to ground. There's very little RF that's going to be across this resistor, and any inductance in there really shouldn't have a load effect on that tube. And I will talk more, as I've been hinting in this episode, about my dilemma over carbon composition resistors versus modern construction ones. Other things to talk about at this point, the assembly process is really going to get into more mechanical assembly on the bottom and top of the chassis, starting with the final amplifier tank coil. Now, I showed in an earlier episode that I found a solution. I did have to get some parts off of eBay. I got lucky at the time that I was searching that somebody was parting out an older DX-60, and this particular final amplifier coil is in excellent shape, especially compared to the one that was in mine. I was facing a real dilemma here of what to do because this end set here of 4 turns is just in terrible shape. At the time I was looking for this, the seller had also packaged the loading capacitor with a flexible coupler and the low-pass filter assembly. Now this is a nice bonus because I was looking at some repairs I'd have to do on the one that I had, at least some cleanup because it's in a really ugly shape. This one is in really good shape. Now I added this little contraption here, this cobbled on SMA connector, because I was characterizing this filter, and I'll show the results of that in a future episode. And then of course this coupler was a nice thing to get too, because the existing one that was in mine was busted, and it was busted in a way that's going to be very difficult to repair. So it's nice to have these parts. And like I said earlier, it's kind of sad to have to take parts from another unit to get your unit working, because now there's one less DX-60 that could be used out there. But sometimes you got to do what you got to do. There's just no other practical choice. Now I think what I'm going to do at this point, because there's so many steps left in this assembly, I mean, I'm on page 19 of the manual, and the last part of the assembly goes all the way up to page 32. I'm just not going to be able to finish this in one episode, nor do I want to rush through this. I'm having a lot of fun putting this together. So I think I'm going to wrap this episode up with a discussion about those carbon composition resistors. This problem that I've been hinting at about the carbon composition resistors all comes down to parasitic inductance. Now, going back a few decades, carbon composition resistors, of course, were the primary choice for all of these Heathkits and just about every piece of commercial and scientific gear. That was the state of the art, the way to make a resistor. And naturally, as time has gone by, there's been better construction techniques, better physics, such as metal film, metal oxide, carbon film, and so on, to the point where all the disadvantages of carbon comp resistors, like their tendency to drift over time with temperature, and they're more noisy for precision circuits, that can be a real problem, especially for low voltage circuits. So probably cost started to creep into it too. So eventually what's happened over the last 10 to 20 years or so roughly is carbon composition resistors just aren't made by big manufacturers anymore. You can still find them with niche manufacturers, and of course you can find a lot of new old stock resistors out there. The main concern for using those newer resistors in older RF gear like this DX-60 that use the carbon comp resistors is the manufacturing methods on those sometimes involve laser trimming or chemically etching a pattern into the resistor element that ends up like a spiral or a helix. So folks are concerned that if that helix or that spiral is significantly large enough, you're going to get additional parasitic inductance in that resistor. And that could be potentially a real problem, especially in a tuned circuit, in a filter, or something else in the signal path that's sensitive to inductance. Now, I'm no expert on this by any means. I've just gotten into it superficially as I've been working on this DX-60 and a few other radios over the past year or so. But what I'm trying to do here is separate the lore from the data. There's just so much misleading information online. Go figure. You get a lot of self-proclaimed experts talking about a particular topic that you end up at both ends of the spectrum. Some folks saying, well, metal films are perfectly fine, don't even think about it, to others saying, hey, they're just not going to work. So getting that data has been very difficult. Even the manufacturers don't include on their data sheets anything to say about the inductance of their resistors unless they're specifically made for low inductance type circuits, and then they're charging a premium for those. So anybody want to pay $3 to $4 for a resistor when you're putting something like this back on the air? I sure don't. I actually am trying to get my own data around this question. I've set up a simple little jig with my nano VNA and have been trying to compare carbon comp resistor performance versus metal film and carbon film and a few others. And I've also started a discussion thread on EEV blog under my alter alias, Mr. Headache. It's actually something I created well over 10 years ago, and certainly years before I got into making Level Up Double E Lab. And I've gotten a lot of great feedback so far, and I hope to be posting some of my own results there in the next few days. And if I can't get to the bottom of this, at least I'll get to a point where I can better decide which resistors I can put in these RF sensitive circuits. And if I do get some interesting results from all that comparison testing, I'll be sure to put together a standalone episode here on my channel to share with you guys. But in the meantime, the repairs and restoration are going to proceed on my DX-60. As always, I hope you guys are enjoying this material and enjoying what I show here on my channel. So until next time, bye for now.